Hey there, JavaScript enthusiasts! Today, we're going to talk about an exciting new proposal that's gaining traction in the JavaScript community. It's called Signals, and it's all about aligning the JavaScript ecosystem. Let's dive in. The proposal for Signals is led by a team of champions, including Daniel Ehrenberg, Yehuda Katz, and Rob Eisenberg, among others. They're working together to create a common model that can be used by frameworks like Angular, Ember, and Vue. The goal is to create a standard that works across multiple frameworks, providing real benefits over framework-provided signals. The proposal includes a fully concrete API that's designed for frameworks to build on top of. It provides interoperability through a common signal graph and auto-tracking mechanism. This means that frameworks can work together seamlessly, without having to worry about compatibility issues. So, what are signals? Simply put, signals are a way to represent state in JavaScript. They're like a value that others can read, and they can be used to create reactive systems. Think of it like a notification system that lets your code respond to changes in real time. The concept of signals has been around for over 10 years, with its first popular appearance in open-source JavaScript web frameworks like Knockout in 2010. Since then, many variations and implementations have been created. Let's take a look at a simple example of how signals work. The proposed API consists of two main parts, signal state and signal computed. Signal state represents a writable value that others can read, while signal computed represents a value that's derived from other signals. In this example, we create a signal counter with an initial value of 0 using signal state. We then create two computed signals, isEven and parity, which derive their values from counter. Finally, we use the effect function to update the DOM with the latest parity value whenever parity changes. The API also includes advanced features, such as untrack and current computed, which are better suited for framework authors rather than application developers. These features are analogous to crypto.subtle and provide more fine-grained control over signal tracking. To understand signals better, let's create a simple application using signals to demonstrate how they can be used in practice. I'll create a simple JavaScript framework that uses signals to manage state and reactivity. For UI rendering, I'll use JSX as a template engine. If you're new to JSX, I've created a video tutorial on how to create a simple JavaScript framework using JSX, which you can find in the description below. To set up the framework, I already installed the Babel plugin to transpile JSX code, create a Babel config file to configure the plugin, add a run script to package.json, and use Webpack Dev Server to serve the application on localhost. When we run the Babel transpile script, it will generate a dist folder with the transpiled code, which will be used by the Webpack Dev Server to serve the application on localhost. There's also a core directory that contains the main code of the framework, including the JSX runtime file, which is used to render transpiled JSX code to the DOM. Install the signal polyfill package provided in the proposal. It's a polyfill for the proposed Signals API, which includes signal state, signal computed, and other signal primitives. I already have the package installed in the project. Let's quick start the web dev server to see the application running on localhost. Now, let's jump into the signal integration with our framework. I already created a state.js file in the core directory to define all state-related functions. I'll copy-paste the code of the effect function from the proposal document. Effect function is a function that takes a callback function and calls it whenever the state changes. It's similar to the useEffect hook in React. I'll add one more function called createSignal to create a signal. This function will return an array with get and set methods to read and update the state respectively, similar to the useState hook in React. That's it. We can now use these functions in our application to create a reactive counter. Let's import these functions in the counter.js file and create a signal inside the component. On click of increment button, I'll update the state using the set method of the signal. Let's run the application and see if it works. Why isn't the counter updating? Is there something wrong with the signal implementation? Let's quickly verify using the effect function to see if the state is updating. I'll add a console.log statement inside the effect function to log the state whenever it changes. The state is updating, and the effect function is being called. So, the issue is not with the signal implementation. The issue is with the rendering of the component. The component is not re-rendering when the state changes. This is because we're not calling the render function to update the DOM. To fix this, we need to make some changes in the JSX runtime file to render updated values to the DOM whenever the state changes. It's a pretty simple fix. When we're appending the element to the parent element, we need to wrap it in an effect function to update the DOM whenever the state changes. Because the effect function is called whenever the state changes, the DOM will be updated in real time. And that's it! We've successfully created a simple application using signals to manage state and reactivity. Thanks for watching, and don't forget to check out the video tutorial on creating a simple JavaScript framework using JSX in the description below. If you have any questions or want to learn more about signals and reactive programming, please leave a comment below. Don't forget to like and subscribe for more tutorials and explanations on web development and technology.